So we're going to start graphing in a whole new system. We have been graphing in what we call Cartesian or rectangular, and rectangular is just this x and y, and we've been doing that all the way until we just hit this last chapter, polar coordinates. Polar coordinates then took this system, and this is really applicable to real world because basically our Earth is round, and so if we were to smush it into a two-dimensional instead of three-dimensional, these little circles would lie on top of each other, and that's why you see like airline when they're doing radar kind of things, they are looking at something on a circular grid. We're going to go into another number system. It's called the complex number system, but first we must understand a little bit about an imaginary number. So imaginary number has this definition. It is a square root of -1, and we're going to call it I. And so I is geometrically a 90-degree rotation. And this is really the essence of knowing anything about I. So over here you can see a faint circle. I only did that so you could kind of see this 90-degree, but we're going to call this our real axis. Before it was our x. Now we're calling it our real axis. The vertical used to be y, and now we're going to call it our imaginary axis. In other words, we're going to call it the I-axis. And so this is in a whole different dimension and system as you saw in the first video. So if I do a 90-degree rotation, if I have 1, this is 1, and I multiply it by I get up here and I get a positive I. If I multiply by another I get this thing called I squared. Well, if I have the square root of -1 and I square it, that's going to give me -1. And you can see it is a reflection of 1 across the origin, and I get -1. If I multiply by another I, I'm going to get I cubed. In other words, I've multiplied 3 i's, I get I cubed. But if I look at the axes, if this is a positive I, this better be a negative I, and that's exactly what it's going to be equal to. So you're going to kind of see this little pattern. So 1I squared is -1. I cube is a reflection, which is -I. And lastly, if I multiply by I to the 4th, I better get a positive 1. Well, I squared gave me a -1. If I square a -1, I'll get a positive 1. So it's a rotation of 90 degrees. In other words, it cycles in groups of 4. Just like our clock cycles in 12 hours, that's called modulo or modular arithmetic. This is cycling in groups of 4. So if I had I to the 35th, I could, if I wanted, simplify that, which we want to do, and it's going to simplify into one of 4 items. It's either going to be I squared, I cubed, or I to the 4th. But we know that I squared is -1, I cubed is -I, and I to the 4th is 1. So it's going to cycle it either into I, -1, -I, or 1, depending on where it lands. Now, I could go around this thing 35 times. So that's 4. There's 8 times if I've made 2 complete circles. Or I could just think if it cycles in 4, if I take 35 and I divide it by 4, I've made 8 complete cycles. And that puts me at 32. So I've taken care of 32 i's, and I'm back to the beginning. Here's 33, 34, 35. So I'm going to end up in this position, which is the same as I cubed, but we're going to simplify that further because I know it is -I from this reflection here. Let's try another one, 72. So I could go around and count 72 i's. So going around here, there would be 4, 8, 16. Well, that's going to get long. So if I take 72 divided by 4, it goes in there exactly 18 times. That just means I have no remainder. I began and ended at the same location, and that's equal to a positive 1. So I is a rotation of 90 degrees. You can rotate around the coordinate, real to imaginary, as many times as you'd like. But if you just think about it, all groups in 4 puts me back at the beginning. I'm either got an I, a -1, or an I cubed, which is a -I, because notice the reflection of these across this origin.